Hello all, this is demonstration of our final year Btech final year project volume rendering using medical data. This project was accomplished by my project partner Pankaj Bansal and myself Abhishek Bansal. We both are students of Computer Science and IT department at JP Institute of Information Technology, Noida. So first of all, I will give you a brief introduction to my project. Uh, First of all, we should get to know what is rendering. Rendering is the process of generating an image from a model, or more precisely, we should say it is scene. A scene file may contain various objects, their geometry, viewpoint, texture, lighting, and shading information as a description in it. From this scene file, we have to generate an image, and whole process of generating image is called rendering. Now, what is volume rendering? Volume rendering is used to describe techniques which allow visualization of three-dimensional data. In volume rendering, we calculate 2D projection of colored semi-transparent volumes. The major application area of volume rendering is medical imaging, where volume data is available from X-ray computed tomography scanners and positron emission tomography scanners. And now problem statement. In this project, we will develop a software to accomplish volume rendering of brain using MRI CT scan data with help of volume raycasting and 3D texture-based volume rendering. We will also be implementing a user interface in which user will be able to zoom in, zoom out, rotate, translate, and mark the model. We have also provided user options to give different transfer functions, and there is a predefined list of transfer functions. User can also insert his own customized transfer function. So this was the introduction. Now this is the complete user interface of our project. Let me introduce you to user interface. This is transfer function editor. Here you can enter defined transfer function which are predefined listed here over here, or you can enter customized transfer functions here. These are the editor for this transfer function graph. Here you enter the data set properties, his file name, its depth, its width, height, and its endianness. This is the transformation panel. Here you can transform your model in Z direction. You can rotate your model from here or from here. You can click on the viewing space and rotate the model. This is the lighting and material property editor. Here you can edit various lighting properties in the scene and material properties. Let me show you. I changed the ambient component of light material. So you can see that there is a slight change in the colors. Here. Similarly, you can change different light properties. You can also change light source color or ambient light color in or all over the scene. And this is the slice viewer. Here you can click and see the slice viewer. Slice viewer will open. This is the slice viewer. In slice viewer, this is the transformation panel, and this is the transfer function panel. And if I change transfer function, you can see the effect in the viewing area. Now I increase the intensity and I scale a model a bit. In slice viewer, basically you can see different slices like this. You can see that we are going through cross sections of the brain. You can also rotate model, increase the intensity a bit more, and you can see slices from different angles. So this was all about the. Now I will tell you how to load a new data sets and set a transfer function. Suppose I want to load a data set of a human foot. I will enter the path here. Data type is 8-bit, and then it doesn't matter when data set is 8-bit, and width, height, and depth are 256, 256, 256. Now I press enter, and here you can see the new data set has come. The visualization of this data set is not proper, so I will now try to apply different transfer functions and visualize this properly. So first of all, I am seeing a lot of transparent area, so I will increase the intensity. By increasing the intensity, you are making more pixels visible. Let me do it 15, and I'm decreasing my step size of raycasting algorithm, which will make this model finer. Now you can see it's much more better, a human for dataset. So you can change the colors from here. You can see different styles, colors. These all parameters are just to provide user a better visualization. Now if I enter a customized transfer function, uh, x to the power 3, you just can see that now you can view the skin part of the dataset. Previously you were viewing the bone part of the dataset. Now it's the same dataset, but what you're visualizing is a matter of applying the right transfer function. That's why we have provided you with a separate transfer function editor which gives you many options. Again, I'll come to define, you can see different transfer functions. So this is how we view a new dataset and apply various transfer functions on it. Now I will show you how to visualize a tumor in any dataset by using slice viewer. Now entering a dataset which has a tumor deficiency. The 16-bit data, big endian, width is 512, and depth is 256. I enter it. Here you can see the data. Its visualization is not very proper because of this MRI thing at the back. Now I directly open the slice viewer. This is the appropriate transfer function. Increase the intensity, scale him a bit, I change the projection type to orthographic. Now I'm going to translate this dataset in a Z direction. Here you can see that we are moving through cross sections of the brain, and this is the tumor as medical professional identified. You can see the cross sections of the brain in the slice viewer. You can also rotate model and see cross section from a different angle, tumor from a different angle. Here is the tumor from this angle. So this was the slice viewer and tumor visualization. Now let me enter another dataset. Its width is 256 and depth is 176. This is another dataset. You can see this is the skull of a person. I open a slice view, and here it is. I increase the intensity, orthograph, scale it. This time I will show perspective. Scale it a little less and translate it. Translate XY also. You can see a tumor here. It's not quite visible to us. Scale a little less. Try rotate it and translate it again. Here you can see the tumor. change the color so it can be more visible. Now it's more visible. It is the tumor. So this is how we visualize a tumor in any data set by using slice view.